All right, and then here's how to do 4b. So you need to remember, if you're just given in some ordinary fraction and we're told to do this, generally with division of fractions, you just change it to multiplication and write the reciprocal, and then you multiply the top, multiply the bottom. So that's the basic principle we're going to follow. So what we're going to do then is I'm going to take that problem. I'm going to take the first bit, 5m plus 10 on m squared minus 2. Now I'm probably going to have to factorize that, and I'm probably going to need to factor this, and we can probably even factor that. But I'm going to rewrite it with the reciprocals first, and then, so I'm changing it to multiplication. I'll do this and then we'll work on factoring it. So I'm flipping the other fraction, changing it to multiplication, flipping the fraction around. Right, so I've done the reciprocal. Okay, so now let's factorize this. So that is kind of what I was explaining today. I'll need, if m squared times negative 2 would give me negative 2m. So my PSF, my P is negative 2m squared. My F's going to be negative 1m. My S is negative 1m. And my factor of negative 2, it's got to be positive negative 2 and positive 1. So if I add negative 2m to 1m, I'll get the negative 1m. So m squared minus m minus 2 is going to become m squared minus 2m plus m for the 1m minus 2. So that would factor to m minus 2 plus, and then there's already an m minus 2 there, so I'm just factoring out 1, m minus 2. So that factors to m plus 1 times m minus 2. Okay, so I'm going to rewrite that as 5. You probably clearly can see there's a factor of 5 in that top one, so I'll factor 5 out of that as well. And then that bottom bit became m plus 1 and m minus 2. All right, so that's that one. I'll factor the 3 out of that. That'll be 3, and that'll be m plus 1. On the bottom, okay, this is a perfect square. Okay, now just so I don't have to explain perfect squares, just like I factored this one using PSF, I can do the same thing with m squared minus 4, but it's actually m squared minus 0x minus 4. Right, there actually is no x term, so I'm calling it 0x. So if I do PSF on that, like I've been showing in class, the product is negative 4m squared. The sum has to be 0. So I need factors of 4 that add up to 0. Well, that'd just be negative 2 and 2. Right? So if I multiply negative 2m and 2m, I'll get 4m squared. So this m squared minus 0x can be written as m squared minus 2x plus 2x minus 4. So this would factor to those first two, factor the, I've confused m, I've thrown an x in when it's just an m. Sorry, minus 2m and an m plus, so minus 2m plus 2m. So I could factor an m out and I'll get m minus 2. And on the other one I can factor out positive 2, so that'll be m minus 2. And so it factors to m plus 2 times m minus 2. You do that enough, eventually when you see a difference, not a perfect square, but a difference of squares, where you're subtracting two squares, it would just be m minus 2 times m plus 2. Or if that was like m squared minus 25, it would be m minus 5 times m plus 5. So that m squared minus 2 is factoring to m plus 2 times m minus 2. Okay, now hopefully you're seeing lots and lots of common factors, right? That m plus 1 can cancel out that m plus 1, that m plus 2, cancel out that m plus 2. This m minus 2 and that m minus 2, because they're both in the denominator, don't have a canceling effect with one another. So we'll just leave them as they are. We could either multiply them back together or leave them factored. It's probably better to leave them factored. But so I've still got 5 and 3 on the top, so 15 would go on the top. 5 times 3 is 15, and then it would just be m minus 2 times m minus 2. And that would be a completely simplified factored form of that. Anyway, I hope that makes sense to you. And let me know. You can email me back or ask me in class if that doesn't answer your question.